Hello, hello. It's good to, yeah, it's good to be here. Let's talk about boring Ruby code. So when your Ruby code is boring, it's easy to understand because like there is nothing complex in it. You just read it and you can understand. It's easy to understand for your colleagues, and it's easy to understand for junior developers that join your team. And it's also easy to understand for you after 6 months when you look at your own code and you're trying to figure out, oh, what the hell I meant 6 months ago. It's easy to read. When the code is boring, you look at it and there is nothing hard in it. You can just parse it quickly, look through the lines. And the important thing is that we spend most of our time on reading the code, not on writing the code. So it makes sense to optimize for the reading experience. Boring Ruby code is also easy to delete because when something is boring, you are not attached to it. Like, it's boring, I can delete it, I don't care. And that's a great value. OK, so now I can slow down a little bit. I got my most important points through. And yeah, so the key to understanding this talk is that it's a 20-minute talk, but I will deliver in 30 minutes. I gave this talk at Brighton RubyConf. The format was 20 minutes. And honestly, I don't have much more content to add to it. Like, just that's what I have to say on the topic. So I just added a few jokes. And yeah, I hope that you're OK with that. It's very hard to speak after Ben and somehow like make a good impression. So I will try. I'm also quite impressed that he managed to talk about Elm without mentioning the magic keyword monad, which is a scary thing to say. That props for him for that. It's my first time in Nashville. And before coming here, I didn't know that there is a full-scale replica of original Parthenon from Athens in Nashville. And let me read some part from Wikipedia about it. It was built in 1897 as part of the Tennessee Centennial Exposition. Originally built of plaster, wood, and brick, the Parthenon was not intended to be permanent, but the cost of demolishing the structure, combined with its popularity with residents and visitors alike, resulted in it being left standing after the exposition. Now, if that's not a perfect metaphor for software development, then I don't know what can be better. It's also my first time in US. Yay! That means I can have some stupid questions. For example, why the cars are so big? Why nobody's walking? Where's the public transport? Why you have to pay for the healthcare and for education? But excuse me for these questions. I'm sure I will learn. Also, when I travel, I try to read a little bit about places. And I'm a huge fan of maps. So I picked one map to learn a bit about Tennessee. So that's the map from the last presidential elections. That didn't make me super happy. But it's always important to dig a little bit deeper. And when we look at the state, it looks different. Yay, that's great for me. Now, I live in Berlin, which is known for its kind of weird culture. It's a little bit more anarchy there, so there are some squats. It's also known for its electronic music, scene powered by drugs, and sometimes it's difficult to understand. That's my company. We are based in Berlin, and we already have one successful case of relocating somebody from US to Berlin. So if you find yourself in a position where you want to change your environment, you're welcome. Berlin is open to everybody. So we already know, after the presentation yesterday, that talking about good code is pretty hard. That's why I want to speak about boring Ruby code, but I don't want to make it as a set of principles or rules or some just follow this, that's the right way. And the structure of my talk is that I'm going to show a bunch of examples of code that is smart. So we will look at a few code examples. These code examples will present not the boring code, but the smart code. And I realized that programmers like to look at the not so good code that wasn't written by them and laugh. That's, I don't know, that's some kind of like a weird thing that we just look at it and we say, oh, it's like, that's a shitty code. That's so funny. I'm not the person who wrote it. Yes. Yeah. So basically, that's my idea for the talk. And yeah, I don't expect it to have many takeaways. Just follow me and laugh a little bit. I hope that it has some value in itself. It's also real code. It comes from GitLab, and I pick it because of a few reasons. The first reason is that I worked for GitLab as a full-time paid open source contributor for a while. The second reason is that it's a fairly large Rails application, so you can find many weird things in it. And the third reason is that it's open source. So if you are curious, you can go to the repository and check it out by yourself. So let's start with an example which is kind of innocent. Let's look at this. And by the way, I will have quite a lot of code in the presentation. And first comes the black and white version, and then I have a highlighted version. So here, we have a bunch of fields properties on object to initialize. And instead of doing it one by one, we are smart. We make an array of these properties. We iterate over every element, and we use send to initialize these properties on the object. We don't have to do that. We do that. We can. That's Ruby. That's kind of innocent example. That's OK. But let's move on and look at this one. Here we have a similar situation. But this time, we are lazy and we don't want to define similar methods. So what we do is we have an array of method names, and we use define method, and we dynamically define these methods. The boring example would look like this. So just 3 methods. They have kind of similar structure to each other. There is some repetition, but I mean, they are only 2 lines long. And now, let's look back at the smart example. That's so much more dry, right? That's like we avoided this repetition. That's dry. Awesome. Let's look at a similar example. So now we have even longer code snippet. But the important things are here. So again, we have a list of methods. And again, we use define method to dynamically define these two methods. This time it's two. It's not even three. It's two methods that we want to define. But if you take a closer look at the body of these two methods, you will notice that this highlighted part in blue is not dependent on the method name. So in fact, we could simplify this and say that its new position is some transformation of new position. So we can fold this to a single line. And now, this boring example looks like this. So we just define these two methods. They have a similar structure, but it's just a single line. And we extract a method, some transformation, whatever the name, and this is shared. And the takeaway here is that we reached for metaprogramming to avoid code repetition, but we were so focused on using metaprogramming that we forgot about the most basic method, the most basic method of refactoring, which is extract method. That's the most basic thing that you can do. You have repeated code, you extract a method. But instead of doing that, we were like, yay, metaprogramming, let's use define method. And we ended up with code that's more complex. Now it's my story time. And my favorite stock photo. Just look at it. My personal goal is to someday give a presentation and have the audience looking at me as these people are looking at this guy. So the story starts in GitLab Codebase when I encountered this line of code. Before action, authorize download code, bang. And when you want to add some more code, you usually first have to read the code that's around it. You want to at least go one level deeper and have a better understanding. So I wanted to find the definition of authorized download code to make sure that it does what I think it does. So I fire my text editor to do a search across the whole project. Because, come on, we are in Ruby, dynamic language. So yeah, find in all files is our best friend when navigating the code. And by the way, I also use a boring text editor, Sublime Text. And now, what I'm going to say now probably won't make me too many friends. But I think that in the war between Emacs and Vim, Sublime Text is the ultimate winner because it's boring. It's a boring code editor. It's simple and boring. You don't have to have any special skills to use it. It's just boring. I love it. So let's go back to our story and to searching for authorized download code. We do this, and we get a very, very scary thing. 0 results. Where is this method defined? Does it come from some library? How can I find the source code of this method? And after, I will save you 30 minutes of my time where I did some exploration. But in a parent-parent controller, I found this. And that's the highlighted version. And please Take a closer look what we do here. So we have a method missing, and inside this method missing, we do a regular expression matching on the method name. And if the method name starts with authorize and ends with bank, we do a special thing. Now, that looks like somebody playing hide and seek with me. Just somebody really wants me not to find this method. That makes it super hard to find this method. And now, is it really worth it? Like, how much time does it take to define these methods? Probably a little bit, but you do it once. And then people will search for it multiple times. They will waste this half an hour multiple times, all other programmers that touch this code. Okay, let's look at another example with method missing. That's some highlighting. So we have method missing, and we use send to dynamically dispatch the method to two places. But if you take a closer look here, we check if the method name is a particular symbol. And that's method missing. Method missing, by definition, is a place where we have code that handles a missing method. So what's the point of checking for the particular method name? Can't we just define this method? Won't it be simple? That looks smart. You look at this, you see method missing, you see send, you see block given, stuff like this. This looks smart and a little bit scary. So you just skim through it, and you continue reading the code. You kind of assume that it makes sense. It looks smart. So you say, OK, this looks smart. Probably somebody smart wrote it. It has some meaning. You don't criticize this kind of code. It tends to stay in the code base. And that's another example with method missing. So we have method missing. We have send. We have yield, some stuff. But the important part is here. So in method missing, that is intended to handle cases when object doesn't respond to a method. We check that it responds to the method. So according to me, everything after the first line is a dead code, because it will always return. But it's here. It's here in the code base. It kind of looks smart. We assume that it has a meaning. And maybe it has. I mean, so far, nobody was able to explain to me that in certain cases, it doesn't work like that. But if I spend time thinking about it, then probably a lot of other people will spend time thinking about it. So even if it has some very particular use case, that's probably not worth it, because you just waste people's time. Yeah. Let's move on to the next example. Here, we redefine a square brackets operator, and we do const get and some metaprogramming magic. And it has a small convenience. We can use this fancy square brackets operator in some other places, and it saves us maybe 10 characters. But the thing about redefining a square bracket operator is that it's kind of hard to find places where it's used. So once we define a method like this, getting rid of it is super hard. And the test coverage says that this line of code is never invoked. This method is never invoked. And I try to find whether it's the case or just like that some test coverage is missing. It seems that this method is never used. But this method will probably stay there forever because nobody can notice that it's not used. It's super hard to analyze that. So when you have a smart code, it tends to stay in the code base because it's difficult to find places where it's used. Now, let's talk about code that tries to accomplish way too many different things. And it can start in quite an innocent way. So here, if you take a look, this method accepts an argument that's called project ID. And then inside the method, we use isA to check if project ID is an instance of project, and we do something. Or if it's not, we do something else. So that's just like one branch condition, right? We added one if statement. It's clear that project ID, in this case, can be an instance of project or project identifier. So when we look at the signature of the method, it's already confusing. But these are two cases. That's OK, right? Like we can live with that. But let's move on to the next example. Here, it's a wall of code. That's a lot. I don't want you to read all of it. Here we have some things highlighted. So here, our argument is target. And then we check if it responds to a certain method, and we do a certain thing. Or if it responds to a different thing, we do something else. Or maybe it's a string, and then we do a third thing. Or maybe just nil. And so here we have 4 different options. And it's clear that it's not a single type. Just this method can accept multiple different arguments, multiple different types, and somehow tries to handle that. And if we keep it localized to a single method, that's not too bad. Like, that's an if statement, right? One if statement. But here, we call a different method, passing the same argument, target, to it. And so let's explore the body of this method. It's also long. It looks quite complicated. And here are the highlighted interesting places. So here we have 4 places where we check the type of the argument, and we do different things based on this type. And the takeaway here is that once we start using this respond to or checking for types, it tends to spread around the code base. It doesn't stay in a single place. You add it here, and then you add it in another method, and yet another method. And then your whole code is cluttered with this kind of things, a bunch of if statements. This can also lead to very confusing cases, like here, where we use respond to check for if particular object responds to map. So we check if stdiff can have map method defined. But we immediately pass it to a different method. So it's looking at this piece of code, it's super unclear why we check for map. Is map needed inside this other class? Does this class somehow rely on the existence of map? And what if we change the implementation of the class? Will we remember to come here and update this code, remove this respawn to? Probably not. And the last thing that I want to show is some code where we have some existential questions. So that's the piece of code. And we can just read it with a proper intonation. If node is a node, right? That's some kind of an existential question. Doesn't it look weird to you that the variable is named node, and then we check for its type with its node? I mean, the name of the variable suggests that it is a node, but for whatever reason, we have to double check that. That just looks funny in the code base. So let's recap and talk again about the same things that I mentioned at the beginning. Boring code is easy to understand. That's important. You have different levels, different skill sets in your team. Some people are at the beginning of their career, some people at later stages. If you use code that is smart, it will be a problem for your junior programmers. It will also be a problem for you after 6 months, 12 months. You will have problems understanding your own code. I know that I have problems. I think that everybody has problems. It's easy to read when it's boring, and we spend most of the time reading the code. So when we make it boring, maybe we will invest a little bit more time when we write it. But then every person reading the code will be thankful to us. And it's also easy to delete. It's boring, so we have no attachment to it. It's just, oh, these super simple lines, I can remove it. But when you created a nice, smart monster, you develop some kind of feeling towards it. Oh, that's so complicated. That's like, I'm super smart. Let's just keep it here. And when you look at such a monster created by somebody else, you kind of assume that it has a meaning, right? For sure, there is a meaning for this crazy meta-programming going on here, right? Like, if there was no meaning, then nobody would read it, would write it like that. So you just skip over it and assume that it makes sense, and then it stays in the code base and can be dead code for a long time. Thanks.